Hello everyone. Let's continue ANOVA. Before we go into new stuff, I'm going to talk to you about the classification of ANOVA. Let's go to note. Let's talk about the classification of ANOVA. Remember the gas type case? So we had gas type. Type 1, type 2, type 3, right? We had 5 observations for each type, right? And these ones are called treatments, right? And I didn't talk about this one. This gas type is called a factor, right? And this one is treatment. Okay, so we had one factor and 3 treatments, right? Actually, this treatment is equal to levels of factor. All right. Also, in this case, since we have one factor, this one is called one-way ANOVA. Right? Now, today we are going to talk about two-way ANOVA, right? Two-way ANOVA refers to the case where we have two factors. Let me draw a table again. So we have a factor 1, factor 2. Suppose we have 3 treatments for each factor, right? And we have a total of how many cells? 9 cells, right? So we have observations in each cell, right? If we have only one observation, right, for each cell, this one is called two-way ANOVA. ANOVA with no repeated measures, right? Now, if we have more than one in each cell, right? So we have, let's say, 3 observations for each cell. Then in this case it's called the two-way ANOVA. With repeated measures. All right. So let me summarize this. So we have one-way ANOVA. And two-way ANOVA. Right? And this one is classified into 2 with no repeated measures. With with the repeated measures. Okay. And this case, this one is called the randomized block design. All right. So what is the difference between these two? Okay. Difference between 1 and 2, right? In this case, no interaction effect. Interaction effect. This is the basic difference between 1 and 2, right? So we'll talk about today these ones, okay? 1 and 2, right? And let's talk about a term called MANOVA, right? Sometimes you hear about MANOVA. This one is the basically multivariate ANOVA. Okay. So what is multivariate ANOVA? Suppose you have a region here, right? So you have 3 different regions, and this is the store size. Okay, 1, 2, 3. So you have 2 factors, right? Now, suppose you want to check the sales before advertising and after advertising, right? So actually you observe 2 things, right? For each cell. Same thing here, right? So first one is before sales, before advertising, right? And the second one is sales after advertising, right? In this kind of situation is called MANOVA. So in this case, called the two-way MANOVA, right? Since we have 2 factors, suppose you have 1 factor, then in that case you call it as one-way MANOVA, right? We are not going into this stuff in this semester, but if you hear about the MANOVA, you should know that you have more than 1 dependent variables. In this case, we have 2 dependent variables here, right? That's the basic classification of ANOVA, right? So let's go back to the PowerPoints. So we are back to PowerPoints. Let's start with randomized block design. Remember that randomized block design refers to two-way ANOVA with no repeated measures, right? So let me go to an example here. So this is the defective cardboard box case, right? So we have 2 factors here. One is production method, and the other one is machine operator. Okay. So we have 3 treatments for machine operator and 4 treatments for production method, right? And you see here we have only one observation for each cell, right? So we have only one observation for each of these 12 cells, right? So in this type of situation, it is called a two-way ANOVA with no repeated measures. Sometimes it is called a randomized block design, okay? Now, in this case, there are lots of computations are involved here. So the ANOVA table looks like this. So we have factor 1 and factor 2 and the error here and the total here, right? This table looks very similar to the one we did in the ANOVA case, right? One-way ANOVA case, right? So in this case, we have two F statistics, right? One is for the factor 1 and the other one is for the factor 2, right? We are not go through the computation part, right? I'm going to show you how to use the SPSS for this, and we are going to focus on interpretation of the computer output, right? So let's go to SPSS, okay? So we are in SPSS. I already type in the numbers here, right? So we had the cardboard box case. So we had quantities here and operator here and production method here, right? We had 4 treatments for method, right? And 3 treatments for operator, right? And these are the production quantity, okay? So we are going to use these data, right? Now you go to the analysis here, and at this time, remember that for the one-way ANOVA case, you choose this menu, right? But in order to analyze two-way ANOVA, you go to the this, okay? This one is called the general linear model, right? And you select from the submenu, you select the univariate, okay? If you have a MANOVA, you select this one, okay? But in this case, we choose univariate case, right? So you select this one, okay? I already moved variables here, so let me show you again. Let me return these things, right? So in this case, production quantity is dependent variable, right? So you move to the right, and we had the two factors, right? One is operator and the other one is method, right? So you move these two, okay? Now for the two-way ANOVA, you need to specify your model, right? The reason that you specify your model is that you should specify whether you have an interaction effect or not, right? So you go to the model here, okay? There are two options here. This one is, complete model, and this one is a user defined, right? If you have an interaction effect, then you choose this one, all right? Complete model. And if you don't have interaction effect, such as in our case, then you need to select this one, okay? And you move two factors to the right, okay? right? And you press continue button here, and you will have the results here. So you will have the results looks like this. So you have two factors here, operator and the method here, right? And you have p-values for each of two vectors, right? Right? So we are going to, focus on these results, right? Instead of going through, all kinds of computations, right? Now let me show you the process again, right? And you once you typed in the these numbers, you go to the analysis here, and at this time you select general linear model here, and you select univariate, okay? And you move the dependent variable and the factors to the right, right? And you need to specify your model here, right? In case of two-way ANOVA with no repeated measures, you don't have an interaction effect, so you need to specify your model by using this user-defined, okay? And you move the factors to the right, okay? And then continue, and you get the results, okay? All right, let's go back to the PowerPoints. We are back to the PowerPoint. So let us try to interpret these results, right? So in this case, we have two p-values, right? One is for the method and the other one is for the operator, right? So let's try to understand, these things, right? So we had four methods, right? So what is the hypothesis in this case? In this case, right? So we had a hypothesis like this. mu1, mu2, mu3, mu4. Since we have, four methods, right? And the alternative hypothesis is at least two. At least two of four means differ, right? That's alternative hypothesis, right? So in this case, the p-value is almost zero, right? Right? So since p-value less than alpha is 0.05, let's say alpha is 0.05. So we are going to reject null hypothesis, okay? So rejecting null hypothesis means what? You support alternative hypothesis, right? So that means you see, there are some differences among, these means, right? So you need to go through the posterior analysis, right? Remember that when we do the SPSS practice for the one-way ANOVA, we go through the posterior analysis for pairwise comparison, right? So we'll go through, this stuff again. Now, before we do that, let's look at the operator here, right? In this case, we had three operators, right? So in that case, okay, the null hypothesis is, since we have three operators, right? And same alternative hypothesis, at least two deeper. At least two deeper, right? In this case, the p-value is 0.005, right? 0.005. So p-value is less than alpha, right? This is 0.05, right? So in this case, you are going to reject null hypothesis, right? So there are differences in terms of production quantity among the machine operator, right? So we need to go through the pairwise comparison in this case too, right? Let's go to the SPSS. So we are in the SPSS. So let's do the pairwise comparison. So you go to the analysis. So you select the general linear model and you select the univariate. So we already moved the variables and the factors to the right, right? And then you go to the posterior analysis here. And you move factors to the right. And let's use a 2 key, right? And you continue. And you get the results here, right? Let's look at the operator first. Okay, operator first. And if you want to find pair which have differences, you need to look at the p-value which is less than 0.05. Okay. In this case, this one is very close to 0.05, but still this one is less than 0.05, right? And this one is also less than 0.05, right? So that means there is a difference between 1 and 2 and 1 and 3, right? And in this case, for 2 and 3, since you cannot reject null hypothesis, you can say that 2 and 3 are equal in terms of quantity, right? Now let's go to the method here. In this case, also you need to look at the p-value which is less than 0.05, right? So here 1 and 3 and 1 and 4 and 2 and 3 and 2 and 4. So you see, if p-value is less than 0.05, you reject null hypothesis, right? So that means there is difference between 1 and 3 and 1 and 4. Also, there is a difference between 2 and 3 and 2 and 4, right? So that's it. Now let's go back to the PowerPoints, right? We are back. Let's look at the case of a two-way ANOVA with repeated measures, right? This is a shelf display case. So we have two factors. One is width, right? The other one is height, right? We have 2 treatments for width and 3 treatments for height, right? And in each cell, we have three observations, right? For example, we have three observations for regular width and bottom height, right? And also we have wide width and bottom height. We have three observations, right? And so on, right? This one is different from the case where we have two-way analysis with no repeated measures, right? The only difference is that in this case we have to consider interaction effect, right? Let's look at the computer output first. Let's look at the output here. So we have factor 1 and factor 2, and we have interaction here, right? The output for the two-way ANOVA with no repeated measures, right? We didn't have interaction term here, right? So when we have a two-way ANOVA with repeated measures, we need to check interaction effect, right? So this is the actual output for our sharp display case. We have height here and width here. These are the factors, and also we have interaction here, right? So we have three p-values, right? So obviously we have three types of hypothesis testing going on here, right? So let's look at the this output, right? So let's try to understand this output first, and then we are going to go to the SPSS to get this output, right? Let's look at the height first, right? So we had three treatments for the height, right? So the null hypothesis is this, right? mu1, mu2, mu3, right? So it's a top, middle, and bottom, right? And obviously the alternative hypothesis is what? At least two differ, right? That's the hypothesis for the height, right? And in this case, the p-value is this, right? So p-value is less than alpha, so you reject null hypothesis, right? That's the hypothesis testing for the factor 1, right? What about the factor width, right? In case of width, we had two treatments, right? So null hypothesis is mu1 is equal to mu2, right? So regular and wide, right? So in that case, the alternative hypothesis, obviously in this case, since we have two, right? Two means differ, right? So in this case, the p-value is 0.253, right? So in this case, p is greater than alpha, right? So you cannot reject null hypothesis, right? Cannot reject null hypothesis. That means you need to accept null hypothesis, right? And the last one, let's talk about interaction, okay? Interaction case, the null hypothesis is no interaction. Okay? Interaction exists. Now, in this case, p-value is this one, right? 0.462. So this one is greater than alpha, right? So you cannot reject null hypothesis, right? So that means accept null hypothesis, okay? So there is no interaction, all right? If there is no interaction, that means you need to check whether there is a difference in terms of the means, right? Now, if you reject null hypothesis, that means there is an interaction effect. There is no need to check each individual factor in terms of the mean differences, right? Since in this case we accept null hypothesis, all right? So that means you need to check, each individual factor in terms of mean differences, right? If you reject null hypothesis, right, that means, there is an interaction between two factors, right? In that case, you need to create new sets of data and do new type of analysis, right? So, for example, you create, new treatments like a combination of, width and height, right? So regular and bottom, regular and middle, and regular and top, right? Like that, right? And then it's kind of, in this case, it's a one-way ANOVA. You need to do the one-way ANOVA analysis, right? Let me clarify the situation where we reject null hypothesis, right? So in terms of interaction, so if we reject, right, then there is no need to check individual factors in terms of mean differences. So you don't need to go through the hypothesis testing for each individual factors, right? So if we reject null hypothesis, you need to create new data, like shelf case. You create new treatment. It's a combination of width and height, right? So regular width and bottom height, okay? Regular width, middle heights, regular width and the top, okay? And the wide width and bottom, and the wide width and the middle, and the wide width and the top, right? And we have 3 observations for each of these treatments, right? Right? Once you create, this new data set, you do the one-way ANOVA, right? Right? So if you reject the hypothesis, right, you create new data sets and then you do the one-way ANOVA, right? If you accept null hypothesis, that means there is no interaction, right? In that case, you need to go through the hypothesis testing for each individual factor, right? That's it. And then let's go back to the SPSS and then to get the output for the two-way ANOVA with the repeated measures. All right? So let me show you how to get the output for the case where we have a two-way ANOVA with the repeated measures, right? So I already put the data here, right? This is height, since we have three treatments, right? So I used 1, 2, 3, and we have a width here. We had two treatments, right? So I used 1 and 2, and these are the demand, okay? And then you go to the analysis, right? We use the general linear model, and we use univariate, okay? Now let's return these things. So in our case, demand is the dependent variable, and the height, width are the factors. And then you go to the model here. You need to specify model, right? In this case, we need to have an interaction effect, right? So you need to go to the model here. In this case, you select the complete model, right? Complete model means you have interaction effect, right? And then you continue, right? Also, you may want to do the posterior, right? So you move these factors to the right, and you select two key, and you continue, and you get the results here, right? So in this case, you have height here, and p-values, and the width here, and these are the interaction effect, right? Height times width, right? So in this case, obviously you cannot reject null hypothesis, right? So that means there is no interaction effect, right? So in this case, you need to go through the hypothesis testing for each individual factors, right? Right? So this is the basic output for the two-way ANOVA with the repeated measures. Let me go through this process again. So once you typed in the data, right? So you go to the analysis, right? And then you select this menu, general linear model, and you need to select univariate, right? And then you move the variables and factors to the right, okay? Don't forget to specify model here, right? For the two-way with the repeated measures, you use this complete model, right? To get the interaction effect, right? And then you continue, right? If you want to have posterior analysis, you click this one, and then you select two key, right? And then you enter, right? So you get the results here, right? So that's it. So this is for the ANOVA, and the next time we'll study regression, right? See you next time.